Hello students, and in today's class we are going to talk about the buffer solutions. What are called buffer solutions? In order to maintain the pH of any system, these buffer solutions are highly essential. For example, in our body, the pH of blood is maintained as a constant due to the presence of a composition. This is the responsible acid, carbonic acid, and its sodium salt, NaHCO3, sodium bicarbonate. So the acid and its own salt, this mixture maintains the pH of human blood. Likewise, in variety of chemical reactions, some reactions are taking place only at certain pH, desirable pH. So to maintain the constancy in the pH, these buffer solutions are must. So buffer solutions, what are called buffer solutions? Even after the addition of either stronger acid or stronger base into them, their pH remains unchanged. So when you take a buffer solution, to the buffer solution, if you add either stronger acid or stronger base, we cannot change the pH of that particular mixture. pH remains unchanged, which means the concentration of hydronium ion as well as the concentration of hydroxyl ion are maintained as constant. And these are the two types of buffer solutions we are having. One will be the acidic buffer. What is called acidic buffer? Acidic buffer is a mixture containing weaker acid and its salt. Particularly, we are taking the sodium salt. I am writing an example: CH3COOH, acetic acid, plus CH3COONA. This composition is called acidic buffer. Likewise, what is called basic buffer? The other one, basic buffer. The basic buffer is a mixture which is containing weaker base and its salt. Just see, this is the weaker base, ammonium hydroxide, and its chloride salt is ammonium chloride. So it's the best example of the basic buffer. There are two types of buffer solutions. One is acidic buffer, other will be the basic buffer. So whenever, wherever, if you want to maintain the pH of any particular substance, we must have the buffer solutions there. Just by using the buffer solution, we can maintain the pH in particular value. There are two types. And how this buffer is working, that should be discussed under the topic called buffer action. Okay, buffer solutions, their action is very important to understand the mechanism. How are they working, the buffer solutions? That is explained with the help of this topic, buffer action. We know that there are two types of buffer solutions. First, we can take acidic buffer for our discussion. This is the acidic buffer which is constituting the weaker acid, namely acetic acid, CH3COOH, that is partially dissociated to form CH3COO minus and H plus. And its salt, CH3COONA, it's a stronger electrolyte, completely dissociated to form CH3COO minus and Na plus. And this can be given inside a box like this. It ensures that these are the constituents of buffer mixture. So when you add something, a stronger base or stronger acid into this, how their pH is maintained as constant? Yes, first of all we can add on the addition of stronger base into this, how the pH is maintained. We know this is the stronger base NaOH that is dissociated to form Na plus and OH minus. It means when you add sodium hydroxide, the concentration of OH should increase, but the added OH can readily combine with this hydrogen to form H2O. So our attempt is failed. No increase in the concentration. There is no change in the concentration of OH minus. It means there may not be any change in pH as well as pOH. Likewise, when you add stronger acid into this, on the addition of stronger acid like hydrochloric acid, HCl, that would be dissociated to form H plus and Cl minus. Now, really the hydrogen should increase, the hydrogen ion concentration should increase, but the hydrogen plus can combine with this acetate to form acetic acid. So our attempt is failed. There is no change in the concentration of hydrogen plus, which means there is no change in pH value. Try to understand. When you add a stronger base, the added OH minus combines with H plus to form H2O. No increase in the concentration of OH. Likewise, when the addition of a stronger acid like hydrochloric acid, it provides a H plus, but there is no chance of increasing the concentration of H plus. The added H plus combines with acetate to form acetic acid. So the constancy is maintained in the case of pH because of no change in H plus and no change in OH minus. This mechanism is called buffer mechanism, buffer action, which is applicable for acidic buffer. Likewise, we have to talk about basic buffer. Okay. Buffer action, in which now we are going to talk about the basic buffer. How this is working, the basic buffer solution. Its action is explained as follows. You consider the basic buffer is a mixture constituting ammonium hydroxide NH4OH, weaker base partially dissociated to form NH4 plus and OH minus. And its sodium salt, or we can take its chloride salt here. It is NH4Cl, ammonium chloride. So we can write NH4 plus and Cl minus. So these are the constituents of the basic buffer. Okay, the basic buffer is containing these substances originally. When you add a stronger acid into this, how its pH remains unchanged. On the addition of a stronger acid like hydrochloric acid, that will furnish H plus and Cl minus. It means we are trying to increase the concentration of H plus, but the H plus combines with OH to form H2O. So there is no change in the concentration of H plus, which means there is no change in pH of this particular solution. Remains unchanged. Likewise, the other situation, we can add stronger base into this. On the addition of stronger base like NaOH, that will be giving you Na plus and OH minus. It means we are trying to increase the concentration of OH minus, but the added OH can readily combine with this ammonium ion to form ammonium hydroxide. So there is no chance of increasing the concentration of hydroxide. And we can say that there is no change in hydroxyl ion concentration, which means there is no change in pOH of this particular mixture. So in this way this is working. On the addition of HCl, the added H plus combines with OH to form H2O. On the addition of NaOH, the added OH combines with ammonium plus to form ammonium hydroxide. No change in H plus, no change in OH minus. So there will not be any change in pH as well as pOH. So this is about the buffer action of basic buffer. Okay.